This figure addresses a simple but important principle. The pressures exerted at the depths of the ocean are great because they are the result of the weight of all the water above. For example, the pressure on the hull of a submarine at 300 feet is about 149 psi, and that's half of the pressure exerted at 600 feet, which is roughly 283 psi. The pressure of air at sea level is only 14.6 psi, and that's referred to as 1 atmosphere. Therefore, even at 300 feet of water, the pressure is the equivalent of about 10 atmospheres, or put another way, for every 33 feet of water, the pressure increases approximately 1 atmosphere. The same principle is applicable to air pressure. The greatest air pressure is at or near sea level, and the lowest air pressure will be found at the greatest peaks. Whereas the average air pressure at sea level is 14.6 psi, or 1 atmosphere, the air pressure is only 4.89 psi, or about 1/3 of an atmosphere, on the summit of Mount Everest. This figure illustrates the three ways our atmospheres can be delineated, namely by composition, temperature, and function. In each case, it's the same atmosphere, but simply examined using different characteristics. Composition consists of two layers, the homosphere and the heterosphere. In the homosphere, the different molecules are uniformly distributed throughout the layer. The density of the molecules does, however, decrease with increasing distance above Earth. Conversely, the heterosphere is made up primarily of only the lightest molecules and particles, and they tend to appear in layers and thus are not uniformly distributed. There are 4 temperature layers, and they are distinguished by whether the changing temperatures are positive or negative with increasing altitude. The troposphere is closest to Earth, and in this layer, temperatures decrease as distance from the Earth increases. The source of the heat in this layer is Earth, so as distance from the source increases, the temperature of the atmosphere or air decreases and does so at a uniform rate. The layer just above the troposphere is the stratosphere, and the temperature profile within this layer is for temperatures to increase with increasing distance from Earth. The ozone layer is located within this layer, and it is the ozone molecule's interception of UV rays that result in the rise of temperature. The mesosphere is the next layer, and like the troposphere, temperatures decrease as the distance from the Earth increases. The mesosphere is home to the coldest temperatures in the Earth's atmosphere. And finally, the thermosphere, as the name suggests, this is the warmest region of the atmosphere, as gamma and other high-energy rays are absorbed by the few particles which are found there. This layer is where meteors and auroras become visible to us. Sorry about that. The third method of delineating the layers of the atmosphere are by function and consists of the lower ozonosphere and the upper ionosphere. The ozonosphere is a layer in which UV rays are absorbed by the ozone molecules that are clustered there within while the ionosphere is where gamma, X-rays, and light rays are absorbed by the ions found in this uppermost layer.